Right, last video. This one is on concentration. Pretty simple concept, but some of the calculation questions can be a little bit tricky. Okay, so we're talking about concentration. We're always talking about solutions. Here, I've got 1 gram of sodium chloride. If I dissolve 1 gram of sodium chloride in 1 decimeter cubed of water, a decimeter cubed is the same as a liter, then I'm going to make a solution, so NaCl aqueous, and the concentration is going to be 1 gram per decimeters cubed. Okay. If I wanted to know out how many moles I had per decimeter cubed and have my concentration in moles per decimeter cubed, all I need to do, I'm given mass, I divide by formula mass. So the formula mass of NaCl is 58.5. That's how many moles I have of NaCl in 1 gram. Therefore, my concentration in moles per decimeter cubed is this. Okay, and when I'm writing concentration, I can either write it like this, 1 gram per, so I can use a dash, decimeters cubed, or I could write 1 gram, leave out that dash completely, and have the dm to a -3, which is what I've done down here. So moles per decimeter cubed, or I could have a dash there and not have that -3. If we look at the formula for concentration then, so concentration, if we look at the unit, is moles per decimeters cubed, which is moles over volume. Decimeters cubed is a volume. Okay, we can use that to draw a triangle. Okay, so moles is going to be at the top, concentration and volume are at the bottom. Okay, similarly, I could write concentration is grams divided by volume, and I would have mass at the top and then concentration and volume at the bottom. We're going to go and do some of the questions. Again, as I said, some of these can be a little bit tricky, but we'll look at strategies that you can use to make them a little bit easier. So the first one here, it's about electrolysis, but we can ignore that and just look at the calculation. So you're told that this particular solution was made by dissolving this mass of sodium sulfate in water to make 250 centimeters cubed of solution. They want you to calculate the concentration in grams per decimeters cubed. Now, the unit they give you gives you the formula. Grams per decimeters cubed is grams divided by decimeters cubed. Now, you've got something in grams, but you don't have anything in decimeters cubed. Instead, you've got something in centimeters cubed. Therefore, the first thing you're going to need to do is a unit conversion. So if I want to go from centimeters cubed to decimeters cubed, I am going to be dividing by 1,000. Okay, so 250 centimeters cubed is the same as 0.25 decimeters cubed. All right, now I've got something in decimeters cubed. I already had something in grams, and according to my unit, it's whatever I have in grams divided by whatever I've got in decimeters cubed. So that's going to be 28.4 divided by 0.25, and that is going to be my answer, and I have to give that to 3 significant figures. The next one, basically the same. Okay, they tell you it's mass divided by volume. Even if they didn't give you that, look at the unit, mass divided by volume. You're given mass in grams, that's there already, but again, I'm given volume in centimeters cubed. My unit said it must be in decimeters cubed. So 200 centimeters cubed, again, I'm just dividing by 1,000, is 0.2 decimeters cubed. And then I've got something in grams already, 9.25. I divide what I've got in grams by what I've got in decimeters cubed, and that is going to be my answer. This time you're not asked to specify the number of decimal places or significant figures. If we look here at the next one, this one's a little bit different. So a flame photometer, we haven't looked at photometry yet, we will later on in the course, but we can still do the calculation, was used to analyse samples of solutions of metal ions. We're always dealing with solutions when we're looking at concentration. Each sample was treated with 5 centimeters cubed of dilute hydrochloric acid. 1 decimeter cubed of the acid contains 219 grams. How much hydrogen chloride was the mass used to test 20 samples? All right, so you can do this in a few different ways. Okay, we've got 20 samples to test, and each sample requires 5 centimeters cubed of dilute hydrochloric acid. So I'm going to do 20 times 5 equals 100 centimeters cubed of this dilute hydrochloric acid. Okay, now if I come over here, I can see that if I had a full litre of this hydrochloric acid, it would have 219 grams. So I've got 219 grams per decimeter cubed, and a decimeter cubed is 1,000 centimeters cubed. So if I had 1,000 centimeters cubed, I'd have 219 grams, but I only need 100 centimeters cubed because I've got my 20 samples. Therefore, how many grams do I need? Well, if my volume is 10 times smaller, then my mass will be 10 times smaller. And instead of having 219, I'm going to be dividing by 10 and getting 21.9 grams. The next question here is again a little bit different. So I'm told that copper sulfate solution, again, so it's a solution, has a concentration, this is copper sulfate, of 15.95 grams per decimeters cubed. And they want to know how many moles of copper sulfate I have in 50 centimeters cubed. Because if I write down my little triangle, moles is at the top, and then underneath I need volume and I need concentration. Okay, so moles, which is what I'm asked for, is volume times concentration. Okay, but in order to get the answer in moles, I need my concentration to be in moles. And at the moment, my concentration is in grams. So before I can plug this into my equation and just say moles equals volume times concentration, I'm going to need to put my concentration into moles. So at the moment it's in grams. If I want to go from grams to moles, all I do is divide by mR. So I'm talking about copper sulfate, and I work out the formula mass of copper sulfate. I find that the answer is 159.5. Therefore, moles equals 15.95, so that's grams. So I do 15.95 divided by 159.5, and I get an answer of 0.1. Okay, so that's now my new concentration. My concentration is now 0.1 moles per decimeter cubed. So all I've done is change the unit from grams per decimeter cubed to moles per decimeter cubed because I'm asked about moles. I'm not finished yet. In order to find moles, I need to do concentration times volume. I've worked out my concentration in the correct unit. I need to now multiply by volume. Okay, the volume I'm given is 50 centimeters cubed. Okay, but be careful. Because my concentration is per decimeter cubed, I need my volume to be in decimeters cubed as well. So I'm going to need to take the 50 centimeters cubed, divide that by 1,000 to work out the volume in decimeters cubed, and then I'm going to be able to multiply these two numbers. So I've got 0.05 times 0.1, and I get an answer of 0.005, and that is my number of moles. Okay, so moles, all I need to do is do volume times concentration, but I've got unit conversions to do first. The concentration needs to be in moles per decimeters cubed, so I go from mass to moles by dividing by mR, and then my volume needs to be in decimeters cubed, so I go from 50 to 0.05, just dividing by 1,000. Once they're both in the correct units, it's just volume times concentration, and I get my answer in moles. All right, this next one, to be fair, is a little bit tricky, all right? They tell you that this solution of potassium hydroxide has a concentration of 0.175, and they give it to you in moles per decimeter cubed. And they say when you're actually trying to make this, you dissolve this mass in this volume, and they want you to get the percentage by mass of sodium hydroxide, right? So if you want to get percentage by mass, you need two things that are in grams. At the moment, I've got this in grams, but this is in moles. So the first thing I'm going to do is I'm going to go from moles to grams. Now I'm talking about potassium hydroxide. If I want to go from moles to grams, it's going to be moles times mR. So mass equals moles times mR. Moles is 0.175. Formula mass of KOH is 56. So I times these two together, 0.175 times 56. And I get 9.8. Now I know the concentration in grams per decimeters cubed. So that's the mass I have in a decimeter cubed. But if we look here, the mass they've given us is per 250 centimeters cubed. Now a decimeter cubed is 1,000 centimeters cubed, but we only have 250. So if I've got 9.8 in 1,000 centimeters cubed, how many do I have in 250 centimetres cubed? Well, 250 is 4 times smaller than 1000. So I need to divide 9.8 by 4. And I'll see that I've got 2.45 grams per 250 centimetres cubed. Okay, so I've just taken this concentration and changed it from moles per decimetre cubed into mass per decimetre cubed first, and then into mass per 250 centimetres cubed. And I've done that because they've given me a mass per 250 centimetres cubed in the question, and I need them both in the same units before I can get percentage by mass. So once I have them both in the same, to get percentage by mass is 2.45 over 2.56 and times it by 100, and you'll get your answer. There's more than one way to do that, so I've converted this into grams per decimetre cubed, but you could go the other way. You could turn this into moles per decimetre cubed. As long as they're both in the same unit before you get your percentage, you're going to end up with the right answer. Let's have a look at, is it the last one? Oh, okay, two more. Let's have a look at the next one then. So this one's actually quite straightforward, okay? They give you, they tell you that you are dissolving a gram of calcium chloride and your concentration is 12 grams per decimetre cubed. They want you to calculate the volume that contains 9 grams of calcium chloride. So they have given you two things. They've given you a concentration and they have given you a mass, and they're asking you for a volume, okay? According to my little formula triangle, I can have mass at the top, and I've got concentration and volume at the bottom. I can also have moles at the top, but in this case they're giving me grams. So I've got mass at the top, concentration and volume at the bottom. If I'm trying to find volume, therefore, it's going to be mass divided by concentration. The mass they give me is 9 grams. The concentration they give me is 12 grams per decimetre cubed. 9 divided by 12 is 0.75. And that would be 0.75 decimetres cubed, because I've got decimetre cubed in my concentration. Their volume of solution in centimetres cubed, therefore, I need to multiply by 1000 to go from decimetres cubed to centimetres cubed, and I get an answer of 750. Last one then, a nickel sulfate solution is made. So they give you a mass in grams, they give you the volume in centimetres cubed, but they want the concentration in grams per decimetres cubed. So again, this is one of the ones we did at the start. I've got something in grams already. I need to divide it by something in decimetres cubed. At the moment, I've got centimetres cubed. So I'm going to do 250 divided by 1000, 0.25 decimetres cubed. Now I've got something in grams, 23.5. I can divide that by what I've got in decimetres cubed, and that is going to be my answer.